Please read this disclaimer in its entirety. Rationalizing denominators sounds like something to do with fractions. We care about denominators when adding because they need to be the same. If they're not, we make them the same by finding common factors. This is difficult to do with radicals because we don't know how to factor those. Rational numbers are ratios of integers, so rationalizing the denominator that we want the denominator to be an integer. Let's start with the fraction we just looked at. We know from common denominators that we can find equivalent fractions by multiplying by fractions that are equal to 1. In this case, we want something that will cancel the root of the denominator, which is just the radical expression itself. This works with more complicated fractions as well, even if the numerator is also under a radical. Notice that we leave the numerator in its most simplified form. So this looks ugly. Our first guess might be to square the whole denominator, but when you try that, you still get this part in the middle that has a radical, so that's not going to work. However, this is when we remember that there was a product where the middle part canceled out. Multiplying by the conjugate gives us a difference of squares without that annoying unsquared part. Notice that the 3 is squared, but because of the radical, the 2 is not. All that's left is to simplify the expression. In conclusion, manipulating our fractions so the denominator is an integer is called rationalizing the denominator, and it allows us to more easily use that fraction for other mathematical purposes.